Let's go on a road trip and learn some math along the way.
How are we going to learn math on a road trip?
Well, you can describe the movements of the car using math terminology. The position of the car is how far the car has traveled with respect to the origin, or zero.
Oh, so if the car moves forward 5 feet in 2 seconds, then the value of the displacement is 5 feet at t equals 2.
Exactly, and here's a nifty and drifty formula you can use to find the value of displacement when given an equation.
That's awesome! So how would I be able to tell how fast the car is going?
Let me show you. The velocity determines the speed and the direction of the car. You can use this formula to find the value of the velocity at a given time t.
So then how are the velocity and the position related to each other?
You can find the velocity by taking the derivative of the position equation.
What units would we use to measure the velocity then?
Let's take a look. The car has a speedometer that shows you how fast you're going in miles per hour.
That's kind of cool. Since we're moving forward, our velocity is positive.
Yep.
Wait, if velocity is how fast something is going, what is acceleration?
Acceleration is basically how fast the velocity is changing.
So we could find the value of acceleration if we calculated how fast the needle on the speedometer was going up.
Exactly, but that's really hard to do, so we're not going to do that right now.
Is acceleration related to velocity in the same way that velocity is related to position?
Yeah, the acceleration is the derivative of velocity.
It is important to note that acceleration also has a direction, which is given by the sign of the value of the acceleration. If the acceleration is negative, then the car is speeding up in the negative direction. If the acceleration is positive, then the car is speeding up in the positive direction.
This means that in order to say that the car is speeding up, the acceleration and the velocity have to be the same sign.
Let me explain this time. When the velocity is positive, the car is moving forward. If the car were to be speeding up, the acceleration would also have to be positive, as it would have to be accelerating forwards as well.
If the acceleration of the car is negative while the velocity of the car is positive, the car would be slowing down as the car is accelerating in the negative direction, but the car is moving in the positive direction, meaning it is moving forward but slowing down.
The same applies for the opposite of both of these situations.
Fantastic! That's everything you need to know about rates of changes in natural sciences or speed on the road.
You ready to go on a road trip now?
Yeah!
Cool!